concerns road safety, automatic side stand system in two-wheelers. The main thing is cost efficient one, motive of this project. Today accidents is a major serious issue in today's environment. Mainly more accidents are committed only in using two-wheelers. In those accidents, major thing comes under the misuse of side stands. Problem or our project or idea become a solution. Per year, more than 200 India itself. The main objective of this project is it is fully automating the side stand process. It provides a warning system. Already the available system having only the warning system, not automating anything. Considering automatic side stand system, the thing is interlocking system of relay is a major principle used here. In existing system, manual side stand system, it is by person's aid, by our aid only it operates. Later extension, pneumatic system. Pneumatic system is a heavy one and it occupies more space, and major thing is it's a semi-automatic one. And later than mechanical stands, if we consider, it is also a semi-automatic process, but two main disadvantage of this mechanical setup is it disturbs the engine efficiency, it reduces the engine efficiency, and it is unstable under the wet in rainy seasons itself. It is very disadvantage one in mechanical setups.
So the proposed idea of a system is to fully automate the side stand system, and the interlocking is provided to prevent the stand from extending in traffic conditions when we switch off the ignition switch. The warning system provides gives us a warning when it is in a failure condition. Here the ignition switch controls the relay, and the relay controls the motor which actuates the stand mechanism. So this is a simple block diagram. The ignition key is coupled with the ignition switch. When we switch on the ignition switch, relay is actuated. We have provided interlocking to prevent extension of stand in traffic conditions, and this relay actuates the stand mechanism. We use two DC 12 volt relay coil, a 12 volt gear motor, separate 12 volt power for the motor, and we use HSLA steel for stand lever assembly. We use HSLA especially because high strength, low alloy steel has high mechanical properties, and it prevents corrosion than normal carbon steels. And bolts and nuts and two limit switches to limit the stand actuation.
As far as we consider the mechanical setup, main thing is holder and coupling, side stand lever. This thing. Main thing is holder. In holder, this is a Pro diagram. In holder, motor is coupled, motor is attached to one side, and the other side the side stand. This is the entire setup. The side stand is attached to the holder by means of a coupling mechanism. This is the entire flowing model. As far as we consider the mechanical setup, the coupling is very important in this project. High strength coupling is needed for this process. So we select the mild steel based coupling. This is the thing what we explained in the previous slide. Coupling is motor shaft and the side stand lever.
So the electrical setup consists of ignition switch, relay, and warning system. We use two relays. The relay one is connected to ignition key, ignition switch, and limit switch. It does the process of forward the motor to run in forward condition, and it is also connected with the warning system. The relay 2 is connected with the limit switch 2, and it does the process of rotating the motor in the reverse direction. Here we use relay 1 to actuate the motor in forward direction, relay 2 to actuate the motor in the reverse direction, battery to power up relays and motor. These ignition key and the ignition switch are coupled with the relays. So the main working of the idea is the power supply is given to the key position when the key position is in on condition, and when the ignition switch is on, the limits it is connected with the limit switch which is in normal closed position. The relay 1 gets activated when the ignition switch is in on condition. The relay 1 activates the motor in forward direction, which retracts the stand till it reaches the limit switch 1. When the ignition key is in off position, the relay 2 gets activated, and it extends the side stand and till it reaches the limit switch 2.
As far as we consider the feasibility of the project, this is very simple. The main thing is it is very feasible if we combine this project in the operation itself, that is in engine manufacturing itself. The spare parts of this project is very interchangeable because relay is the main thing. Relay and coupling are the two major things involved in this project. As far as I consider, if we make the relay to attach within itself the globe box, it is very feasible for this project. This is the exact project model or idea what we developed. Coming to conclusion point, what we expect is to fully automate the side stand operation. We have probably achieved that thing, and it's reliable under any condition, unless a mechanical setup side stand mechanism, we face this problem, that is it is not reliable under the wet condition. This overcomes the limitation. And two major limitation of this project is the side stand is in extendable position while we are using center stand. And another thing is the ground clearance. It reduces the ground clearance, but we can increase the ground clearance by entirely fitting the project into the manufacturing process itself. This is a future scope. While using a solid state relay, we can reduce the space consumption. We can entirely set up the process into the engine control unit itself. By using the self motor, we can avoid a motor for separately used for side stand automatic retraction and extension.